Hello everyone, welcome to the very first video of our new series Data Structures and Algorithms in Python. My name is Samuel and I am thrilled to have you here. This series is all about helping you master the fundamentals of data structures and algorithms, or DSA as we often call them. Now, why is mastering DSA important? It's not just about solving coding problems, it's about learning how to think like a programmer and designing solutions that are both efficient and scalable. These skills are highly sought after in job interviews, essential for tackling real-world challenges, and incredibly useful for writing optimized code. So without further ado, let's dive in and lay the foundation for this exciting journey. Let's begin by answering the big question. What are data structures and algorithms? So data structures are the way we store and organize data so that it can be accessed and modified efficiently. Think of them as tools or containers, each with its own purpose. For example, imagine storing books in a library. You could stack them on a table, place them in a single row, or organize them on shelves by category. Each approach is a different type of data structures. Algorithms, on other hand, are step-by-step instruction or procedures for solving a problem. Let's go back to our library example. If someone wants a book, how do you find it? You could check each book one by one, or you could search by category, or even by the author's name alphabetically. These are different algorithms applied to the same data structures. So let's take a closer look at data structures. They come in many forms, but the goal is always the same: organize data in a way that suits the specific task at hand. For instance, if you need to access items in a specified order, a queue might be the best choice. If you need to retrieve an item quickly using a unique identifier, a hash table would work better. Understanding the right data structure to use in a given situation is one of the key skills of a good programmer. For example, if you are working with a to-do list, you might use an array. But if you need to keep track of a game's high scores in real time, you might opt for a heap or a priority queue. We will explore all this in detail throughout the series. Now let's turn to algorithms. Algorithms are step-by-step instruction we use to manipulate data. They help us solve problems like sorting a list, searching for an element, or finding the shortest path between 2 points. But algorithms aren't just about solving problems. They are about solving them efficiently. For instance, imagine you need to sort a deck of cards. You could shuffle through them one by one, or you could use a more systematic approach like dividing the deck into smaller piles or sorting those first. This is the essence of what algorithms do. They provide the logic behind efficient problem solving. Now, why are DSA important? The answer lies in its application. First, DSA is a key focus in job interviews. Recruiters often test your understanding of data structures and algorithms because it shows how well you can solve problems under pressure. Second, DSA plays a critical role in real-world application. Think of tech giants like Google or Amazon. They use complex algorithms to make their services faster and smarter. Finally, DSA helps optimize your code, making it faster and more efficient. For example, the difference between a good algorithm and a great algorithm can mean saving hours of processing time on large data set. Now let's look at some real-life examples of how DSA impacts our everyday lives. Search engines like Google rely heavily on algorithms to fetch the most relevant results in milliseconds. Social media platforms like Instagram and Facebook use algorithms to determine what content appears in your feed. When you shop online, algorithms analyze your browsing history to recommend products you might like. And when you use GPS navigation, algorithms calculate the fastest route to your destination. These real-world applications are proof of how integral DSA is to modern technology. There are two main types of data structures: linear and non-linear. Linear data structures include array, linked list, stacks, and queue. In this, data is stored sequentially, making it easy to traverse one element after another. For instance, An array is like a row of lockers where each locker holds one item and can be accessed by its number. Non-linear data structures like trees and graphs are more complex. They allow us to represent hierarchical or interconnected data. A family tree is a perfect example of a hierarchical data structure, while a network of connected devices can be represented as a graph. We will cover these types in detail in upcoming videos. So before we wrap up, let's touch upon an essential concept: time and space complexity. Time complexity measures how the runtime of an algorithm changes with the size of the input. Space complexity, on the other hand, measures how much memory an algorithm uses. These metrics help us evaluate the efficiency of algorithms. For example, sorting a list of 10 items might take a fraction of a second, but what if the list had a million items? The time complexity tells us how the algorithm will scale, and this is something we will explore further in the next video. That's it for today's video. We have covered the basics of data structures and algorithms, their importance, real-world applications, and a glimpse of what's to come. In the next video, we will dive deeper into time and space complexity, breaking down how to analyze and compare algorithms. If you found this video helpful, don't forget to like, comment and subscribe, and hit the bell icon so you don't miss the next episode. See you soon.